You're doing this out of your head, okay? So the only way to do this successfully, I don't mind if you are, in terms of gathering reference, do I want you to look at a cube? Not really. I want you to try and think your way through it. Think your way through the geometry of what's happening. But then again, like if you look at the corner of a wall, and you go, okay, well that's not a single light source though. You know what I mean? But then if you see another wall and it has a single light source, I want you to be looking at things like that, going, okay, well, wait a minute, what's going on? Why is that part darker than that part? Why is that part lighter than, oh, it's because the light is doing this. You see what I mean? And when you watch the videos online, that'll help kind of take you through it. But the goal is this. You want to convince us that your little image there is not actually fake, that it's actually a white object, a white cube in a white corner. Just like the cube itself. This is really basic stuff. If you can learn this, if you can learn how to do this well, you know a lot. Because now the next time you go to draw a building, the next time you go to draw anything that's even vaguely cube-like or box-like, you will know a lot about how to render that more properly. Even if you're doing it completely out of your head. And that's important stuff. So that's the challenge. This is how easy shadows are, okay? Let's do it in 2D first. Delilah's standing here, okay? Here's a light source. Okay? Delilah's on the ground plane. All right, watch carefully. This is how easy it is. So I'm going to refer to this as the light source. Actually, let me do it in red. So this is the light source. If you were to drop a line straight down from the light source until it hits the ground plane, more importantly, more precisely, I would say the plane on which the shadow is being cast. So it could be a tabletop, it could be a ground plane, it could be a wall, But if you drop a line directly towards that plane where the shadow is going to be, this gives you a point that we're going to call the radiation point. The radiation point gives you a direction for the shadow. The light source gives you a length. That's the shadow. That's all there is to it. Seriously. So, what does that look like in 3D? It looks something like this. Okay, again, everyone will keep their eyes up for a second because it's going to happen fast. So, all of these points are arbitrary. They could be anything. But the radiation point and Delilah are both on the ground plane. So if I go like this, watch. Direction of the shadow, length of the shadow, shadow. That's it. Casting a shadow, don't think of the object. Think of the parts. All right, so in this case, I'm not drawing a shadow of a cube. I'm drawing 4 Delilahs standing 1 unit away from each other. Make sense? Yeah. Okay, so again, eyes up, watch carefully. So I can go like this. That's one line, this is the shadow of the first Delilah, right here. So basically what I'm saying is this point the shadow of this point right here falls right here. Now if I do the second one, you see what I mean? And then, hey look, this point is connected to that point, So therefore, that point is connected to that point. Make sense?
Yes.
And it also means this wall is in shadow. Okay, now here's something cool that I want to show you, because you can save yourself a lot of time. All right, you might notice that, okay, well, this one is going like this, okay, is going in this direction. But actually, I don't need to find it. I didn't even need to find that second one, because there's a thing about shadows. If this line is going to the vanishing point, this line's going to the same vanishing point. Do you see that all of these are going to the same VP?
Yeah.
So, if this line is going to a vanishing point, then this line is going to the same VP. And it's going to hit right there. And if you do the geometry, you see what I mean?
That seems so much more time.
Yeah, so you can basically just go like this. Voila. So here's what I need you to understand. This is geometry. This is not the tonal values. This tells you nothing about the tonal values. All this tells you is this is the geometry for a light that's right there affecting that object. So if I had another light source here, I'm going to get a duplicate shadow in a slightly different orientation. But I don't know how strong each one is until you tell me how strong the light sources are. You know, if the one is a flashlight and the other one is a spotlight, well then the flashlight one may not even be visible, because the spotlight will blow it out. Okay, actually, raise your chin up a little bit. Okay, you guys, if you look right under her chin, watch this.
Yeah, I know, Annie.
Okay,
She's all covered
what's
her.
happening is I'm playing with the reflected light. Okay, so if you watch right here, now watch. See, now it doesn't. You have a bright yellow sweatshirt on, so I knew it was going to have a dramatic effect. You know, here, let me describe it this way, you guys. Go ahead and have a seat. Here's something to think about. What is light? Quan.
Is a ray of photons with bouncing.
Yeah, so it's photons bouncing around, little billiard balls, if you want to think about it that way, to give it some physical, understanding. So here's the thing. When this light hits Annie's sweatshirt, Annie's yellow sweatshirt, it creates, in essence, a low-level yellow light source. Now, if we go out in the sun, it's going to be dwarfed in power by the sun. However, any areas that are in shadow are going to be illuminated by that yellow light source where the sun is not affecting it. You see what I mean? Yeah. This stuff gets really complicated, and it's almost impossible to fully imagine. You're always, as a painter, you are always surprised by light when you're painting on location or when you're painting from a live model. You go, oh wow, check that out. And you're always seeing surprising things that you didn't imagine. And then when you see them, if you know what you're doing, you see them and you go, oh, that makes perfect sense. Why didn't I think of that? But it takes reality to kind of remind you of it. Let's say we put a wall back here. Okay? And I'm going to make the wall this tall, because your walls are going to be tall. So let's say this shadow comes up and it hits the wall and we go, what do we do now? Okay, you go like this. So here's the thing. The light source, this is what I want you to memorize. Wait. The radiation point gives you the direction of the shadow. The light source gives you the length. So if you hit a wall, shoot straight up that wall with the guideline from the radiation point until it intersects the light source line. And when it intersects the light source line, that's the end of the shadow. Yeah.
You just keep going like vertically and horizontally. Like, so for example, you have stairs, and you just like keep going.
Yep. Yeah. And there's tricks to stairs that I'll show you later, but you don't need it for this assignment.
I can have a question. I was coming down some yesterday when I was walking home last night. I noticed too, like where the Chavez little arch is, the two lights that were just two little light poles, and they were both like going towards crossing. And I kind of noticed on the ground, like the way the light, it looked like there was 3 different values. Like, how do you explain that? Like,
Yeah, basically there's it's called a penumbra effect. What you're talking about is this, and actually, you know where you see it very commonly is sunlight. Okay, but you don't know it's necessarily what you're looking at. You know how when you're looking at how you can see kind of fuzzy shadows sometimes? What you're talking about is this. Like, let's say there's a light here and a light here. Now, if you have a single object like this, actually let me do it here. If you have a single object like this, what you're going to get is you're going to get a shadow going that way and a shadow going that way. Okay, about equal strength. Guys want to see something interesting? If you watch a night soccer game or a night baseball game, the stadium's ringed with lights. They're all about the same distance from the players. The players are going to have 8 shadows, like going out in each direction from them. Okay, and that's because you're getting multiple light sources, but they're all about the same distance away. Now, so what's going to happen is, let's say we have a wall here. So it's not a point anymore, but it's a wall. What you're going to get is you're going to get this. There's going to be a strong shadow from this one. There's going to be a strong shadow from this one. But if you notice between these two, this area here isn't getting light from either. So you're going to have a deep shadow and then 2 weaker shadows like that. Does that make sense?
Yeah. Yes.
So that's what's going on. Yeah.
Is there a good way to approach the gradation of light on the center?
Very carefully, and it's in the video. Well, see, here's the thing what the videos will do for you. The videos will talk about kind of okay, this is the geometry. The videos will talk about, okay, how to start thinking about the values that are created. But then you guys are going to struggle with it, you know, like everything in this class. And then when you come back next week, I'm going to set it up and I'm going to do a lighting demo for you guys and show you, okay, now watch this. Now watch what happens when I do this. Now watch what, and your brain's going to be like, oh my God, I can't believe I understand this, because it makes so much sense. You know, and it's great because it's physics. There's the right answer. You know, there are certain things that are impossibilities. You can't, when you guys bring back the cubes, I'm going to say, okay, there's no way that can be that dark, and here's why. And I'll explain it, and you guys will go, oh, yeah, that makes total sense.